Okay, so 6.4 is talking about rational functions. And a rational function, I would give you a definition, but it might not make much sense. I'm just going to circle the ones that are rational functions. A, D, and F are all rational functions. The reason that B isn't is because I have a square root in the numerator. This one is not a rational function because it has an E in the denominator. And then E is not a rational function because it has a natural log. So if it has like a special symbol in it, it's not a rational function. If it's just a polynomial on top and bottom, then it's a rational function. Okay, so on 6.5 we're going to graph rational functions, but today we're going to just piece all of our steps together, and then tomorrow we'll graph. So first we're going to talk about a point of discontinuity. Point of discontinuity is the x-coordinate of a point where the graph of the function breaks into branches. A rational function has a point of discontinuity. I think I spelled that right. If A is a number for which the denominator of the function is 0. So remember, you can't divide by 0. So if I happen to get 0, then you get a point of discontinuity. So two things are going to occur. You're either going to get a hole in the graph, like we have here, or you're going to have a vertical asymptote. So those are your two options for points of discontinuity. So you look at the denominator, and you look to see when it would be 0. Okay, so those are just some visuals. Okay, it says find any points of discontinuity for each rational function. So let's go to the next page. That's where the questions are. Okay, so since I'm looking for points of discontinuity, I am looking at the denominator only. So I'm going to cross off a few of these. That should be good. Just those two. So again, I'm only looking at the denominator. Points of discontinuity, you look at the denominator. And you are going to see when you would get 0. So if I set this equal to 0, both of those, you get 4 and -3. So this is where you would have either a hole in the graph or a vertical asymptote. So these are the 2 points of discontinuity. Now this one I have to factor first. I got a difference of perfect squares. So I'm going to set those both equal to 0 and then solve. So I'm going to have a point of discontinuity at +2 and -2. This one's already factored, so if I set those both equal to 0, I'm going to have a point of discontinuity at 0 and at -2. And then the last one, I got to factor that. I'm going to first of all take out an x. I'm going to factor that again, have a difference of perfect squares. And then I'm going to set all 3 of those equal to 0. So I'm going to have a point of discontinuity at 0, and then positive and -3. So let's go back and see our answers. So that's my answer to 1, that's my answer to 2, that's my answer to 4, and that's my answer to 6. Okay, so that's what you want to do first when you're graphing rational functions. Okay, now we're going to talk about horizontal asymptotes. That says that at the bottom. It should be on the next page, but it doesn't. Here we go. Okay, you're going to have 3 scenarios. So you're going to have at most 1 horizontal asymptote. And I'm going to do an example for each. So the first example is when the degree of the denominator is greater than the degree of the numerator. Okay, for example, let's say I have, I don't know, 3 divided by, or 3x divided by x squared. The degree of the denominator is greater than the degree of the numerator. So when that happens, so this is a 2, and that's a 1, that means your horizontal asymptote occurs at 0. Okay, so the second scenario is if the degree of the numerator and the denominator are equal, then your answer is going to be an actual number. A is going to be the coefficient of the numerator, and B is going to be the coefficient of the highest degree in the denominator. So here is an example. Let's say I have 2x divided by x minus 6. Well, this has a 1, and that has a 1. I'm looking at this one, not this one, because this is the higher exponent. Since they have the same degree, then I just look at the ones that have the same. I'm going to divide. So 2 divided by 1 is 2. So this answer would be y equals 2. This one was 0. Okay, the last example is if the degree of the numerator is greater than the degree of the denominator. Then you do not have a horizontal asymptote. So for example, let's say we have x squared minus 6x divided by x. So this is the higher exponent in the numerator. This is the highest exponent in the denominator. This one's bigger than this one, so there's no horizontal asymptote. So you had 3 scenarios. It's either going to be y equals 0, none at all, or y equals a number. Okay, let's try to do some examples here. Okay, so I'm going to look at the degree of the top and the degree of the bottom and then see what happens here. So I'm looking at these two. This doesn't have any x's, but this one does. Therefore, the denominator has a higher degree than the numerator. So that means it's my first scenario. So y equals 0. Number 8, they have the same degree. So if I divide those, I get 1. On this one, I have to do some kind of manipulating here. If I were to FOIL this out, I don't care what all of it's going to be, just the first term. So I'm going to get x squared on top. And if I distribute, again, I only care about the first term, I get 2x. My numerator has a higher degree than my denominator. Therefore, I do not have a horizontal asymptote. The next one, if I divide those two, they have the same degree. So since they're the same, I'm going to divide the 2 and the 1. So my horizontal asymptote is 2. Okay, 11. Let me look at my leading terms there. This one has an x to the first. This one has an x squared. The denominator has a bigger degree than the numerator. Therefore, it's y equals 0. And then finally, the last one, if I look at my leading terms, they have the same degree, so I just divide the coefficients. So the horizontal asymptote is 3/2. So that's how you find the horizontal asymptotes. Now we're going to talk about vertical asymptotes. So we're on the last page already. That's good. Okay, So vertical asymptotes means that, what did I do here? If they have, and I'm going to explain this more when I get down to the bottom, they don't have any common real zeros. If they don't have any common zeros on top and bottom, this is the numerator and denominator. If they don't have anything in common, then it's going to be vertical asymptote. If the numerator and denominator do have something in common, we'll call it A, then there's going to be a hole in the graph. So here's how you're going to determine whether you have a vertical asymptote or a hole in the graph. Okay, first thing you want to do is factor, which it looks like for the most part they're factored except for maybe this one and this one. Anyway, we'll get to those. So I first of all need to find my points of discontinuity. That's where I look at my denominator. It's going to be a -2 and a +2. Those are my points of discontinuity. So based upon that, I'm going to see if I have a vertical asymptote and or any holes in the graph. Well, since those cancel out, that means they had something in common. Since they have something in common, there's a hole in the graph. There's going to be a hole in the graph at 2 something. It's going to be an ordered pair. Because really, this is where the 2 was. If I set these both equal to 0, this one's the -2 and this one's the +2. I'll tell you how to find that in a second. The vertical asymptote is going to be an equation. It's the one that didn't cancel out. This one canceled out, so that was the hole. This one didn't, so this one's -2. Okay. Let's go to 14. So first I'm going to find, and I'll find this in a second. First I want to find any points of discontinuity. That's where I look at the denominator. So 0 and +1. Okay, after I write that down, I'm going to decide if I have any vertical asymptotes and or any holes in the graph. Well, since this canceled, which was the 0, that's going to be a hole in the graph. Whatever didn't cancel, that's the vertical asymptote. Okay, moving on to 15. So it looks like this denominator can be factored. Okay, so that means that my points of discontinuity are going to happen at -1 and +1. This one gives you -1, this one gives you +1. Okay, so now I'm going to figure out if I have any vertical asymptotes in my graph or any holes. Well, nothing canceled. I don't have any x+1s or x-1s on top. Neither one of these cancels. So I do not have any holes in the graph. These are both going to be vertical asymptotes. So I have 2 vertical asymptotes on this one. Okay, number 16. So I can't factor anything. That's not a perfect square, so I gotta leave it like that. Okay, first of all, my point of discontinuity is -2. Since nothing cancels out, I don't have any x+2s on top, this does not cancel out. So since it doesn't cancel out, that is the vertical asymptote. It's only a hole if something cancels. Okay, 17. Looks like it's already factored. So the points of discontinuity, this is going to be -4/5, and that's going to be +3. Nothing cancels, so since neither one of these cancel, they're both vertical asymptotes. No holes in the graph. Okay, finally, the last one. Well, then I have to go back up to here. That's fine. I got a factor. Let's see here. The numerator, let's do the denominator first. The denominator is a difference of perfect squares, so x plus 2x minus 2. This one, let's see, I'm going to guess and check. So 5x and 3x. 2 should probably go here. 2 and 1. That's going to give me 10 and 3. I want a negative. Okay, so now it's factored. So I'm going to find my points of discontinuity, which are going to occur at -2 and +2. Nothing cancels out, so those are both vertical asymptotes. And I can maybe condense it like that. Okay, now let's go up and look at the ones that had holes in the graph. Here's how you find, now the holes in the graph are always going to be ordered pairs. So if something does happen to cancel out, you want to rewrite your new equation. So all of that canceled out. Well, you're left with, so there's nothing on top, there's only a 1 on top, and then you have x plus 2 on the bottom. So you're going to take this number and you're going to substitute it into the new equation. So if I put 2 here, I'm going to get 1/4. So that's the hole in the graph, and that's the vertical asymptote. Okay, on this one, those canceled out. So since nothing's on top, I have a 1 there. There's actually a negative. I'll put the negative on top. I'm going to put 0 into my new simplified equation. That's going to give me 0 minus 1, which is -1. -1 divided by -1 is +1. So that's the hole in the graph. And we're going to practice more of this when we do 6-5, and then we're going to graph it.